In this lesson, we're going to discuss the vertex form of the quadratic equation. When you learned about linear equations, there were two forms that you could write your equations in. In this example, 2x minus 3y equals 10 was called standard form. But we could rewrite it to another form to help us gather more information about the line. That same equation above can be written here as y equals 2/3 x plus negative 10/3. This was called the slope-intercept form because it told us the slope of 2/3 and the y-intercept of negative 10/3 for this line. The quadratic equation form in standard form is like this: y equals 3x squared minus 6x plus 5. We can rewrite this into what's called the vertex form, so we can easily find the vertex. The vertex form is written as y equals a times x minus h quantity squared plus k. In the form y equals a times x minus h quantity squared plus k, we can learn two things. The vertex is represented by h and k. Also, the a in front can tell us if the graph opens up or down. If a is greater than 0, it opens up, and if a is less than 0, it opens down. If a graph opens up, it is said to have a minimum. If a graph opens down, it is said to have a maximum. So your vertex is basically your minimum point or your maximum point. We're going to first walk through how to write the equation from standard to vertex form. I've left the form up in the upper right corner so you can see where we're going to end up. I'm going to do this in a couple of different ways. Different books and different teachers have taught it different ways. It's based on the completing the square method. So I will show you two different methods, very similar, and you can decide which method works for you. So in my first method, what I'm going to do is I'm going to rewrite this equation, but I'm going to take the first two terms and separate them out. So I have 3x squared minus 6x, and I'm going to sort of leave some space here and move the plus 5 over a little ways. So now I can take the 3x squared minus 6x and I can factor out a 3. Our goal here is that we need to have the x squared have a 1 in front of it. Because just like in completing the square, we want to make a perfect square trinomial. So we take half of the negative 2 and we square that. So negative 2 divided by 2, negative 1, and negative 1 squared is plus 1. Now, because this is an equation, we've just added a 1, but the thing is, technically, if I were to distribute that 3 through these parentheses, I've really added a 3 to this side of the equation. So to cancel that out, adding that 3, I can simply write here a subtract 3, which would then cancel those two out and keep everything even. Now I'm going to rewrite this with the perfect square trinomial written in squared form. So I end up with 3 times x minus 1 quantity squared. Negative 3 plus 5 is going to give us a positive 2. And so now we have the information to find our vertex. The vertex formula says minus h, so since this is minus 1, our vertex is going to have an x-coordinate of 1. And it's plus k, and this is a plus 2. So our y-coordinate of our vertex is 2. So our vertex is 1, 2. You'll also notice that 3 is greater than 0. So that means that I know this is going to open up. Now let me demonstrate, and I'm going to do it this way, a little bit closer to the completing the square. For some students, this just is a little bit easier for them. So to do that, again, I'm going to focus on just the right side, and I'm going to ignore the y equals for the moment. So in this case, I could treat it as if y was 0 and go back to my completing the square method. So the first thing I'm going to do still is I'm going to just break these apart. But instead of leaving the plus 5 here, some people might find it easier because they're used to moving the 5 over to the other side, so then that works for them. I'm still going to factor out a 3 here. The reason we can't divide out the 3 and get rid of it is that in the total end of our parabola, that 3 is going to affect the size of our parabola, just not the x-intercepts. Now, I'm going to do the same thing. I'm going to take half of -2 and square it. And so I'm going to end up with x squared minus 2x plus 1. And since we're used to whatever we do to the left side, we do to the right, I can now say, well, I've actually added 3 times 1, so I'm going to add 3 times 1 on the other side. This will get me -2. When I come back, I'm going to again rewrite this in quadratic form. There we are squared. Bring that -2 back over, and it becomes a +2. So we still have the same equation. We still will get the vertex the same way, 1, 2, and we still know the parabola opens up. So now I'm going to have you try y equals 4x squared minus 16x minus 7. You will write it into the vertex form of the equation. You can use either method that works for you. Pause the video, give it a try, then you can restart the video, and I will demonstrate the solution in both ways that I've shown you, and you can check your work against it. Let's go through this. So I will go through it once with the first method I showed you, and then again with the second method. First method, I'm just going to rewrite my first 2 terms and separate them from the constant. So I'm just going to move the -7 over here a little ways. I'm still on the same side of the equal sign. I'm going to go ahead and now factor out the 4, which gives me x squared minus 4x. Now at this point, I need to do the perfect trinomial, so half of -4 is -2. -2 squared is 4, so plus 4. But again, what am I doing? I'm basically actually adding 4 times 4, which is 16. So now that I've added 16, I need to subtract 16 from the same side in order to keep everything balanced. So now I have my 4. I have my x minus 2 quantity squared minus 16 minus 7. That's going to give us a minus 23. So from here, I can get my vertex hk. Now again, this was minus h, so this is going to be a positive 2. And it was a plus k, and I have a minus 23. So that means it's going to be a negative 23 for my y value of the vertex. Now I'll do it again with a little bit closer to the completing the square method, if this just helps you to keep track of what you're adding and subtracting. So again, I'm going to ignore the y equals, and I'm just going to bring down the 4x squared minus 16x minus 7, but I'm going to work it as if I was working at completing the square problem. So I'm going to add a little equal sign here so that I can just do this, 4x squared minus 16x, and I'll move my minus 7 to the right, because I'm used to that with the completing the square. But still, to do the vertex form, I can't really get rid of these numbers, so I need to factor out the 4 to get x squared to have a 1 in front. So I still have 4 times x squared minus 4x, still equal to 7 on this side. Still going to do the perfect trinomial. So, as before, divide by 2 and square, we're still going to get minus 4x plus 4. Now I've added 16 on this side really, because again, 4 times 4. So I could look at it as adding 16 to 7. And now I have my perfect trinomial, whoops, squared is equal to 23, but to be in vertex form, I simply move the 23 over. So we're left with 4 times x minus 2 quantity squared minus 23, just like we had in the previous equation. And our vertex is still going to be 2, negative 23.